All right, guys. Good afternoon. I want to once again appreciate you guys for choosing this class. More so as you are preparing for your JAMB exam that will be coming up maybe in 2 weeks' time. I think by next week you start reprinting. So please,
9 distance.
yeah, okay. So please, I want you guys to really practice more problems. And by now, I feel we have covered a lot of topics, up to like 15 topics or more. So please and please try as much as you can, go over them. The other ones that we are yet to cover, we'll definitely cover them. So I'm working on a plan whereby I'm going to record all those complex topics such as magnetism, um, radioactivities, uncertainty principle, and so on. Just like we are treating these special topics on basic electronics. So we are going to wrap up with basic electronics today, and we shall continue with other complex topics tomorrow by God grace, both in mathematics and physics. Then the biology teacher will also do the same thing. So there's possibility that we look for another chemistry teacher also, that the chemistry class is not going to flop since our chemistry teacher is having challenges with network and probably his gadgets. So we're going to get somebody who can replace him so that we are not going to delay you guys progress in class. All right, so having said that, in our last class we look at the diodes, that is basic electronics. Then we start with the diodes, where we talk about the type of semiconductors, intrinsic and extrinsic, and we move it down to the concept of junction diode and Zener diodes. So if you have not watched the class, I'll link the class in at the comment section, like the description part of this video. I'm going to put the link there so that you can follow up and know how we get to the concept of a transistor. So today we shall start by looking at the concept of a transistor. Just like I did for the basic electronics, such that you can easily remember everything on your head, is the same thing I'm going to do for the transistor. Now mind you, the concept of transistor is very voluminous. In other words, it's a complex word. But as JAMB is concerned, I will focus this class on what matters to JAMB instead of what matters to the topic in general. Then when you get to university, if you are doing electronics, you can do more of it and tend to understand a lot about transistor. But nevertheless, I'm still going to take you through some deep part of it so that you have an idea of what is happening even when you get to the university. But we are going to focus more on what JAMB want to ask you on this particular topic. Now, when you talk about transistor, what exactly is transistor? A transistor is a device, is an electronic device that can be used as what's it called? As a switch. So you can use transistor. Okay, let me put it like this. When you say transistor, you are talking about electrical device that we use as a switch. So you can use it for small current. So if you want to drive a very large amount of current using a small current, you can use transistor. Are you getting it now? Using small amount of current to drive a larger amount of current in diodes, or you can use them as amplifier in AC signals. So that's what we refer to as transistor. I'll take it again. It's an electronic device that can be used as a switch. You can as well use it for a small current in order for you to drive a larger amount of current. Now, we have different types of transistor. We have field transistor and we have BJT. Let me just call it BJT. When I say field transistor, we call it okay, let me just give you the acronyms. So we have a transistor called FET, and we have the one called BJT. When we say FET, transistor that we call FET, the full meaning of FET means field effect transistor, and the meaning of BJT means bipolar junction transistor. I'll take it again. Transistor is an electronic device that can be used as a switch, or that can be used for a small current to drive a larger amount of current. And it can also be used as an amplifier for AC signal. They are of two types. We have FET, which means field effect transistor. We have BJT, that means bipolar junction transistor. When we talk about FET, we have two most common FETs. We have what we call MOSFET, and we have what we call IGFET. For BJT also, we have what we call MPN, and we have what we call PNP. Now, when we say MOSFET, what does MOSFET mean? MOSFET means metallic oxide semiconductor field effect transistor, while IGFET means insulator gate field effect transistor. While for BJT, that we call bipolar junction transistor, when we say bipolar junction transistor, we are talking about what? A transistor with two poles. A transistor with two poles. For FET, we have a transistor with three poles. Because when I say transistor, it can also be called triode. Are you guys following? Okay. So, as far as JAMB is concerned, that is, for this level of academic learning, we are more peculiar about what? BJT, the bipolar junction transistor. Please, guys, can you hear me?
Yes, sir.
Okay. Bipolar junction transistor. So this is the one we want to look at. Now, when we say NPN, what does NPN simply mean? We get NPN when you combine two junction diodes. You know, the junction diodes, we call them NP or PN, as the case may be. So if this is what you have, if I have two of this, and I decided to connect the positive pole and positive pole together, that is, this is the positive pole and this is the positive pole of this. If I connect it together, I will have a transistor like this. I will have a transistor that looks like this. So this is going to be N, and this is going to be P, and this is going to be N. So joining P and P together is what gives us NPN transistor. Now, for every transistor, they have the following characteristics. They have what we call collector, they have what we call emitter, and they have what we call base. So for NPN transistor, this side, that is the left hand side, is the emitter, and the right hand side is the collector, while the center is the base. Now, what if they want to use diode to represent this diagram? Instead of having the diagram like this, what if you want to use diode? For you to be able to remember, this is a symbol for diode. So this is a diode. Now, if you have a diode like this, anywhere this side is pointing towards, Anywhere this sharp end is pointing towards is the N. That is the N-type semiconductor, and this base side is the P-type. So that means this is the positive, that is the anode, and this is the negative, that is the cathode. Am I making sense now? Positive and then negative. So if I want to use this to represent what a NPN transistor, how will I draw the diagram? So for NPN transistor, I will have the diagram to look like this. I will have the diagram to look like this. All right, sorry, that triangle is not perfect. Okay, so let's have it like this. Of course, all of these are what you just need to master. As for this level, you just need to understand the symbols. Those are ways in which examiner will test you on this particular topic. Okay, so for NPN, so if you want to use diode to represent it, you have something like this. Okay, so I'm going to have this. So I have this and I have this. So this will be straight like this, and I have this here. Okay, so this is going to be the bipolar junction. This is going to be the emitter. This is going to be the collector. So have you seen this now? So this diagram represents what? The NPN transistor. So anywhere you see this arrow pointing towards, that is the N, and this straight part is the P. So this is NPN. So this is going to be the base, this is going to be collector, this is going to be the emitter. I hope you understand this. Now, the current, the amount of voltage that this particular transistor can give you, or the maximum voltage, it ranges within 0.6 to what? 0.7 volts. It is a constant value that you need to memorize, so that when you are given what? When you are given a question that has to do with calculation, you can be able to solve it successfully. Alright, so that's for NPN. What about for PNP? So for PNP transistor, I have it to look like this. Sorry. So for PNP transistor, I have something like this. So this is going to be P, N, P. So for PNP, here is the collector, and here is the emitter, and here is the base. These are the three poles of a transistor. So remember. So diode, if you are going to represent this one with a diode, then you are going to have the diagram to look like this. Please try as much as you can to memorize all these diagrams. They are very, very important. Okay, so I have it like this. All right. So I'm going to have it to look like this. So this place is going to be your emitter, this place will be collector, and this place is going to be your what? Your base. So you can see that for PNP transistor, you see that this one is pointing towards the base. Are you getting it now? And because these are the things you need to watch out for. And for NPN transistor, you see that it is pointing away from the base. So please master that very well, because I've seen a lot of JAMB questions that they will give you diagram and ask you that which of the following transistor is NPN or which one is a PNP transistor. So you should be able to identify them, and that's the reason why I'm breaking them down like this. Now, these are the diode representation of a transistor, either PNP or NPN. So if you have this now, what about the electronic symbol of all these diode? Let's take for instance that you want to go and buy transistor. How does transistor look? Let me give you an example of 2N222 NPN transistor. So if you want to buy the transistor, it always looks like this. A transistor looks like this. You are going to have the name on it, NPN. Then you have the value at the top here, 2N222. So this is how it looks. You have this straight line here. You have this. You have this. So this one at the center tends to be longer than the ones at the end. And some can be the same thing, as the case might be. So this is going to be the what? The emitter. This is going to be the base, and this is going to be what? The collector. So this is the symbol when you want to buy transistor. So this is what it looks like. Now what about electronic symbol? That is electrical symbol for transistor. Electrical symbol. For example, if you are reading a chart, maybe they give you what? A chart by electric circuits. How do you identify what is it called? A transistor in the circuit. Remember, if I have something like this, if I have something like this, if I have this, if I have this, and I have this. So when you see this, what symbol is this, guys? What does this one represent? Is there anybody there? Hello? Okay, is it, are you guys not hearing me? Maria and Olufumi.
Sir, we can hear you.
So I'm asking, what symbol is this one?
I think a resistor now.
I'm talking about this. What symbol is this? What symbol is this? What symbol is this? Because these are symbols that you need to understand very well.
Sir, the first one is of resistor.
Resistor. Okay, this one is resistor. What about this?
Current.
Wow.
Voltage.
Okay. I think we have a lot of work to do right now. So when you see this symbol here, this particular one I have here, this is a cell. Or you can call it DC signal. So this one represents a battery. This one represents a resistor. And this one, if the lines are equal, it represents a capacitor. So if you see something like this, if you see something like this, if you see something like this, so this one represents AC signal. That is AC current. Am I making sense now? So if it is now a transistor, for a transistor you have this. For a transistor you have this. So I have a circle like this, then a straight line like this, then you have this, and then you have this. So okay, let this one go up like this. This one should come down like this. Then you have this like this. So if you have this kind of a symbol, let's say the arrow is pointing towards this side. So if you have this kind of symbol, this is a transistor. So what type of transistor is this? So if you look at it very well, you see that the arrow is pointing outward. So since the arrow is pointing outward, you have it to be NPN. and this place the emitter is always connected to the ground, and this place is going to be the collector, and this place is going to be the base. So the collector for NPN transistor, the positive pole is the collector, while the negative pole is the emitter. Am I making sense now? Likewise, if I have the diagram to look like this, if I have the diagram to look like this instead, and I have this go like this, and I have this coming like this, then this one is like this. So this one is going to be the base current, and this is going to be the collector, sorry, the emitter rather, and this is going to be the collector. So if I have the arrow pointing towards this, mind you, the arrow is always on the emitter. The arrow is always on the emitter. So if it is from the emitter pointing towards the base, so this is going to be a PNP transistor. Am I making sense now? So this is going to be the base, this is the emitter. So the collector is what is connected to the ground, and the emitter is going to be the positive pole. So this is the electrical symbol for transistor. So you can see what makes us understand that this is NPN, because the arrow on the emitter is pointing outside the base. And what makes us know that this one is PNP? The arrow on the emitter is pointing towards the base. So for NPN transistor, the emitter is connected to the ground. For PNP transistor, the collector is what is connected to the ground. Now, let us understand how current flow in a given resistor. Let us look at it a little bit if we try connect it in the circuits. Okay, so let me say I have a transistor like this. So if I'm given a transistor like this, you just have to master all these things that we are saying. It might seem boring because it's not really being taught in school. So this is positive, and this is collector, and here is emitter. So if I connect the emitter to the ground, so you should know that that particular transistor is going to be NPN, since it is the emitter that is connected to the ground. That will be NPN. So if I have this and I connect the base. If I connect the base to a transistor, connecting the base to a transistor, what does it mean? And why do I need to connect the base to a transistor? Sorry, to a resistor rather. So if I connect the base to a resistor, the resistor also has to be connected to the positive pole, just like the collector. The currents, that is the base currents, I'll have the base currents to flow through this place. Are you getting this now? And I will have the collector currents to flow in this direction, and the emitter currents is going to flow to the ground. It's going to flow to the ground. Now, guys, I want you to understand something here. If you have this connection like this, current run through the base. Are you getting this now? And why is the current moving in this direction? It's because for a transistor, it is very good for you to make use of conventional currents instead of you using electron. So if you use conventional current, it allows you to understand how current flow in this particular transistor. So the current flow into the base for NPN transistor. For NPN transistor, current flow into the base. Are you getting this now? Then current flow from what? The collector down to the emitter. So the emitter current is going into the ground. Now, what's the significance of this resistor? Why do we have this resistor here? We are having this resistor here in order to reduce the amount of current that will enter into the base. Because if the current that enters into the base is too much, is going to result to what? A larger amount of current in the collector, which will result to the heating of this transistor, and having what? The transistor heated, then you are going to have the transistor destroyed. So if large amount of current should enter through the base, then it can damage the transistor. That's the essence of what? Applying the resistor here, so that it's going to reduce the amount of current that enter through the base. Am I making sense now? So that's that for NPN transistor. So let us look at PNP transistor. So if I have a PNP transistor like this, for PNP transistor, if I have something like this, so okay, let me just finish this so that I can quickly recall what I've been saying since. So if I have this like this, so for this I'm going to have you know, okay, so this is going to be my collector since I'm dealing with what? NPN. So for PNP rather, I have my collector connected to the ground, and this is going to be my what? Emitter, which is going to be the positive pole. So I will have the arrow pointing towards the base, and then I have this is the base. So if I have something like this, then I'm going to connect what? I'm going to connect my resistor in this direction. Okay, so if I have my resistor in this direction, okay, so this is going to be my base, and for this the base current is flowing in the outward direction. Are you getting this now? The base current is flowing in the outward direction. So please, all these things are what you just need to master as far as this topic is concerned, because these are little things that examiner want to test you on for this particular level that you are. So for NPN transistor, current flow outside what? Outside the base. For NPN, current flow inside the base. Are you getting this now? The collector is what is connected to the ground for PNP, while for NPN, it is the emitter that is connected to the ground. For NPN, you have the arrow pointing towards the base. For PNP rather, you have the arrow pointing towards the base, and for NPN, you have the arrow pointing away from the base. What's the significance of what? Of the resistance that we have? It is to reduce the amount of current that enters into the base. Are we together now? Alright, so if that should be the case now, as the current flow away from the base, you have current flowing from the emitter to the collector. So I have this to be the emitter current, and this is the collector current, so flowing in the downward direction. So this one is going to the ground. Am I making sense now? So these are things that you should understand when it comes to transistor. Is that taken now? Okay, so what other things do you need to understand? Another thing you need to understand, let me first quickly recall something for you. So if I have what is it called? Conventional current. Conventional current, you should know that conventional current always flow from high region to a low region. Are you getting it now? It flow from high potential to a low potential for conventional current. While electron flow from region of low potential to region of high potential. So we are making use of what? Conventional current in transistor, so that we are going to understand the flow of current in it instead of using what? Electron. Am I making sense now? So this makes it so easy for us to understand the flow of current in a given transistor. So what other things do you need to understand about transistor? What you need to understand about transistor now is that you just need to understand the formulas that we use in transistor. Okay, so let's understand the formula used in transistor. So formula to be familiar with. So when you are dealing with transistor, what are the formulas that you need to be familiar with? So here are the formulas that you need to be familiar with when you are dealing with transistor. So you have one, you have the collector current is given as beta, where beta is the AHFE. So we have that beta multiplied by the base current, that will give you the collector current, and from here we can have that emitter current is equal to the collector current plus the base current. Am I making sense now? So if this should be the case, we replace this what this collector current, replace it with beta multiplied by the base current. You therefore have what the emitter current to equal to beta multiplied by this plus this, and this implies that the base current into bracket beta plus 1. So that will give you the emitter current. So this is a basic formula that you need to understand as far as transistor is concerned. Alright, so if you have understand this, let's take a look at a question underneath. So let's say you are given a transistor. Okay, so in most cases, when we're dealing with all this kind of problem under transistor, the most widely used transistor is the NPN. Okay, so you know, in future, maybe when we are still sticking to this channel, in future, I'll make a video on why it has to be NPN that we majorly use most in transistor circuits like this, or problem involving transistor. Okay, so but for now, let's focus on this. So now let's take for instance that this is a circuit given to you now, and you have this to be your collector. So collector currents. So this is going to be your emitter. Is connected to the ground, and you have emitter current here. Then the base current. So let's say you are given the base current to be 50 microfarad. Microampere rather, I say farad. So if you are given the base current to be 50 microampere, so you are asked to look for the emitter current and the collector current if the HFE is equal to 200. That is beta. So if beta is equal to 200, so how do we go about that? So we can easily get our collector current since we have the base current and we have what the HFE, that is the beta. Since collector current is equal to beta multiplied by what? By the base current. So we have that IC is equal to 200 multiplied by 50 microampere. So that will give us 10,000 microampere. So 10,000 microampere is equivalent to 10 milliampere. Now let's calculate for the emitter current. So the emitter current is going to be the collector current plus the base current. So that will give us 10 milliampere. Okay, so let me just use the microampere. So that will be 10,000 microampere plus 50 microampere. So that will give us 10,050 microampere. And 10,050 microampere is the same thing as saying 10.05 milliampere. So if you have this to be your emitter current, you can see what can you really say about this. You guys see that the collector current is approximately, or let me say the emitter current rather, the emitter current is approximately the collector current. So why do we have that the emitter current is approximately the collector current? Is because whenever you have your beta greater than 100, then you can say that emitter current is approximately the collector current. Because if you are given a question that has to do with a very difficult circuit analysis, this is very going to help you in making what's it called? This particular condition is going to help you to make your calculation very, very easy. Am I making sense now? Are you guys with me?
Yeah.
Okay. So what other things you need to know about what transistor? especially the NPN transistor. So another thing you need to know is if I connect it in the circuits. Let's take for instance that I have this kind of a circuit. Let's say I have this circuit here, and this is collector resistor. Or let me just take it like this so my circuit diagram will be very easy for me to draw. So let me draw my transistor first. Alright. So if I have this, so take this one down like this, this is going to be grounded. So this is the emitter. You have to get yourself familiar with all these symbol. It's very, very important. You can see I keep on hammering on it just because that's exactly what examiner wants to test from you at this level. At this level, that's what they just want to test. So all these ones I'm showing you, they are just extras. So at this level of learning, what examiner really want to test are these particular diagrams. So you have to master them. So this is going to be the emitter, and this is the emitter. So that means here is connected to the ground. Okay. So at this point, I have what is it called? I have my resistor. Yes. So this is going to be the collector resistor, and this place is my collector. So this is my emitter. Alright, so if I connect this like this, I can connect this to a resistor. Okay, so let's say this is a emitter resistor, sorry, base resistor. Okay, I'm coming. So let me take this down like this. So and this will be the base. So let me just have some space here. So this is going to be the base resistor. So if I have this is going to be, let me put another resistor here. So this is a emitter resistor. Now, if I have this, if this is the diagram that I have, let's say the current I have here is 9 volts. Sorry, the voltage here is 9 volts. You might be wondering, where are we going to put battery? So for you to put battery, you just connect the battery like this. The positive pole of the battery is going to be connected to this. That is, the positive pole of the battery will be connected to the collector, and the negative pole of the battery is going to be connected to the emitter, just like this. Alright, so this is the voltage here. Now currents, the voltage that will flow through this, you have this to be VE. That's the emitter voltage, and here we have the collector voltage, and at this point here I have the base voltage. Now if I connect a millivolt to this particular point here within this two region here, I'm going to have that VCE, the voltage around here is going to become VC minus VE, and VBE, that is, if I connect it here, I will have this to equals to VB minus VE. And mind you, this voltage is just within, this voltage is within 0.6 volts to 0.7 volts. It can be maximum than that. So you have to know all these constants so that when you are solving questions on it, you know how to go about it. Alright, so VCB, that is here, within here and here. So I'll have this to be VC minus VB, and VCC, that is the voltage that flow through this through this point here. You have it to be 9 volts, which is the voltage given, and you have VEE, So the voltage here, so since this one is flowing through the ground, that will be 0. Okay, so this is 0 volts here. So we call it ground voltage. So the ground voltage is 0. Am I making sense now? Okay, so the last part of the class, before we summarize everything in terms of what you should easily remember, is when we consider transistor as a switch. So if I'm considering a transistor as a switch, let's say I have something like this. Here is a transistor. So if I have a transistor like this, and I connect what? A diode to this place. So connecting a diode to this place, let's call this diode D1. So this is going to be a green LED. A green LED, light emitter diode. So this light is what will make you understand if the switch is on or if it is off in a given cycle. So remember, this circuit is to show the use of a transistor as a switch. So let me have a mic battery here. Mic battery is a 9 volt, the 12 volts. Okay, I think that one is 9 volts. So let me just have this. Okay, let me have a 9 volt battery here. So, and I have, let me have a resistor here. So this resistor is RC, and then I have my base. Let me say this is my switch, and I have a resistor here. So this is base resistor. So let me just go in the center here. I have something like that. So I have this. So this is base resistor, and this place is grounded. So this place is ground to the ground like this. So the currents that flow in this direction here is the base current, and the current that will be flowing between what the LED and the transistor here is going to be 0 because the switch is open. Are we together now? So if the switch is open, current will not flow here. That is, the amount of current flowing here is going to be 0, and this LED light is not going to on. Are we together now? So no current is flowing through the base if it is off. So once this switch is off, this switch S1, once it is off, that is, you have it open, there will be current flowing into the base. Once there is no current flowing into the base, there will be what? The LED light is not going to on. Once the LED light is not on, no current is going to flow through the emitter. So this is the emitter, this is the collector, and this is the base. Is that taken now? But the reverse will be the case if you switch on the switch. There will be current flowing through the base, the LED light is going to on, and there will be current flowing through this particular place. Is that taken now? Alright, so that's that about that. So in a summary, we can classify what we can use what is it called? We can use a transistor as an amplifier. So when you say you use transistor as an amplifier, using transistor as a amplifier, you have it to produce large output power or voltage from a DC or AC. So amplifier means you put in small voltage. You put in small voltage, that is input. The input is small, then the output voltage is what? Is large. So that's what we refer to as amplifier. So when you have negative feedback that reduces distortion, so negative, you can also refer it as a negative what? Negative feedback. Negative feedback that reduces distortion. Distortion. How do you know? So when the frequency cannot be changed, So the frequency cannot be changed. So whenever you are using transistor as an amplifier, it allows the input voltage to be small. That is, it allows the output voltage to be greater than the input voltage. It allows negative feedback that reduces distortion. You won't be able to change the frequency. The frequency will remain the same. Okay, so when we talk about amplification, amplification can be divided into some parts, that is different classes. We have the first class, that is the class A. So we have the first class, we have it as a collector current flow all times, where collector current flows all time. That's the first classification, that is the classification A. Bias before the cutoff, biased before cutoff. And 3, have least distortion, have least distortion. Okay, so for the classification B, we have our 3 classification. For the second classification, collector current flow only during the positive half circle, and you have bias at the cutoff. You have high distortion. Okay, so I think we should just, okay, what am I saying? Okay, let me just look at using transistor as a transducers. So you can use transistors as a transducers, that is energy converter. So for example, for loudspeaker, it converts electrical to sound. It converts what? Electrical to sound in a loudspeaker. So it is what's it called? It is transistor that we use to convert electrical energy into what? Sound energy. In a photocell, it converts what? Light into electricity, and so on like that. So that is what we refer to as using what's it called? Transistor as a transducer. So if that should be the case now, let's take some questions on that transistor. Are we there, guys?
Yes, sir.
Okay. All right. So for the first question here, the question is that the number of p-n junctions in a bipolar junction transistor is. So how many p-n junctions? How many p-n junctions do we have in a bipolar transistor? So option A, we have 1. Option B, we have 2. Option C, we have 3. Option D, we have 3. Sorry, we have 4. And option E, we have 5. So which one is going to be correct? It says the number of p-n junctions in a bipolar junction transistor is. How many p-n junctions do we have there? Is anybody trying to answer that question there? Are we there? I'm not sure. Is it that our mic is not working or we don't just feel like talking?
2, sir.
Okay, so please let us always respond very fast so that we can move on before we can have a lot of some times to relax before the biology class starts. All right, so we have 2. So for when you say PN, how many junction diode we have? Bipolar junction transistor, that is BJT. They include what? MPN and PMP. So this means you are having junction diode PN. So this junction diode. So if you connect to what? two junction diodes together, you can either have what, PNP or NPN, depending on the poles that you connect together. So the correct answer is going to be 2. Thank you, Maria, for that. Okay, so another question here is, okay, in bipolar transistor, in bipolar transistor, in bipolar, in bipolar transistor, in bipolar transistors, condition, sorry, conduction rather, it's a conduction. In bipolar transistor, conduction is by, in bipolar transistors, conduction is by A, charges and currents, charges and currents. Then B, electrons and position. C, electrons and holes, electrons and holes. And for D, electrons only. So which one will be the right answer there? The question says that in a bipolar transistor, conduction is by A, charges and currents, B, electrons and position, C, electrons and O, and D, electrons only. Is there anybody trying to give us answer there? Hello, are we there? No response.
Electrons and holes.
Electrons and holes. So that's correct, because when you talk about bipolar transistor, they are made up of junction diode, and for junction diode, the charge carriers there are electrons and holes. Therefore, conduction will also take place with conduction and holes. Sorry, electrons and holes. Okay, this is 2001 question 47. The question says that a transistor functions mainly as a switch and amplifier, switch and amplifier. B, rectifier, and amplifier. C, charge storer and amplifier, charge storer and amplifier. D, charge storer and switch, charge storer and switched. So which will be the right answer there?
Switch and amplifier.
Switch and amplifier. So because the switch amplifier shows the current behavior, and the amplifier shows the current behavior, and the switch shows the voltage behavior. So that's correct. A transistor functions mainly as a switch and amplifier. Okay, so the next question here states that transistors are used for the transistors are used Transistors are used for the A, conversion of AC to DC. Okay? Conversion of AC of DC, sorry, and B, amplification of signal, amplification of signals. C, rectification of signal, rectification of signals, and D, conversion of DC to AC. So what will be the right answer there? Can we still see the screen? Hello, are we there? So the question says transistors. Are we there, guys?
Sir.
So the question says that transistors are used for the A, conversion of AC to DC, B, amplification of signal, C, rectification of signals, and D, conversion of DC to AC. Alright, so the correct answer is going to be for amplification of signals. So conversion of AC to DC or conversion of DC to AC, that has to do with rectification, and you can only use junction diode for rectification. So we use a transistor for amplification, not rectification. Is that taken now? Okay. So another question here states that this is 2005 question number 4. So we're given that the question is this. So we have this, we have a transistor like this, and then I have this, and I have this. Okay, so this one is pointing towards the inside, and I have here to be P, and I have here to be R, and then I have here, okay, seems something is wrong with my network. So are we having this now? So let's just wait for the network to connect. Okay, I really don't know what's going on right now. The network is full here. Okay. I hope it's not what I'm thinking. Okay, are we out of data or something? Okay. Alright. So give me some minutes to quickly rectify this. Okay, I think the network is back now. Okay, so let me share the screen. So because these are questions that JAMB usually asks more, so and for that reason there's need for us to look into it. Okay. Alright, so back to this. So we have here to be R, and we have here to be Q. So the question says that in the circuit diagram, in the circuit diagram, in the circuit diagram of a transistor, the terminals P, Q, and R, the terminals P, Q, and R represents, so we are told that Q, R, and P, what do they represent? Respectively, A, base, emitter, and collector. B, base, collector, and emitter. C, emitter, base, and collector. And D, collector, emitter, and base. So what does that represent? So P, Q, and R, what does P represent? What does Q represent? What does R represent?
Emitter, base, and collector.
Emitter, base, and collector. So correct. So that's why you see they not really ask you any complex questions. Now I say JAMB on this particular topic is just the elementary and majorly on the diagram. Okay, let's see another one. They say which of the following diagrams represents an NPN transistor? Which of the following diagram represents an NPN transistor? Okay, so we have this. The question is which of the following diagram represents an NPN transistor? Okay, so this is B, and you have this one to go in. So this is B, sorry. Okay, we are told that this is C. Okay, I think they call everything C. Don't know. Alright, so the next one, you have this. You have this. You have this. Okay, so this one is pointing like this. Then you have C, you have B. Okay, so another one, which is option C. You have this. There's a big problem here now. Okay, so this is B. So it's pointing towards like this. And the last one, okay. Alright, so in order for me to, I think there's a typing error here. So let me just call this one the emitter, the collector, emitter, collector, emitter, collector, emitter, collector. So which one represents MPN? Is option A, option B, option C, and option D. So which one is MPN there?
Option B.
Option B. Okay, so MPN is option B, whereby you have the arrow on the emitter pointing away from the base. So that's correct. Alright, so I think this would be a good place for us to stop. Okay, yeah, this will be a good place for us to stop since we have been able to touch virtually all areas of questioning under this particular topic. Okay, so I urge you to solve more questions on it. There are still more questions under this in a tricky way. So thank you for making it to today's class. I so much appreciate each and every one of us. So in some minutes time now, the biology class is going to commence. Yeah, so I think okay. So let's say on or before 4:30, we are going to commence the biology class by God grace. So any questions so far on this topic before we call it a day? I think what was it called? Fumi, yeah, Fumi. What? Okay, Olufemi. I've been calling you Fumi since. Olufemi, is there any reason why you didn't talk throughout today's class? The same thing goes to Wangba. The same thing goes to Wu again. Okay, Murray KJ have not been talking in class since. That is Badura. Alima, it seems he just joined us. Okay, Alima left. Today, what happened? You didn't say anything throughout today's class. Any problem? Is it that you don't understand the topic or you are not in a place where you can talk?
Sir, I just joined.
Okay. What about today? Today have been here since I think she started the class with us, or she just put on her phone and far away from it. Okay, I guess that's what happened. Maybe she just come online and just drop the phone. What about Prissy? I think you are just joining us. Okay. Okay, I think Balua also just joined. Alright, so let's just prepare for the biology class. By 4:30, the biology class is going to commence. So I'm going to do some work on this now. So I'm going to share it for those that missed the class so that you can watch the replay. And I'll also try to break down some of the cycle diagram and upload them on my WhatsApp so that you can just see something unique about them. Alright. So thank you for making it to today's class. Okay. Okay, so they say it seems our mic is not working. It seems our mic is not working. Okay. All right. So see you guys tomorrow. Yeah, we shall see tomorrow in mathematics class. Thank you.